and let's start rocking it with our problem of the day. This one's already creating quite a stir on the internet. Well, not a big one, but it is catching some eyes on Facebook and catching some answers and some new faces on there, which I appreciate. Glad to hear from you all, giving us some possible solutions that you see to the problem of the day. A coin bank has 30 coins worth $5.70, consisting only diamonds. I wish it were diamonds, right? Only dimes and quarters. How many of each coin? All right, let's take a look at this. 30 coins, $5.70, and all we're allowed are to have dimes and quarters. So there's some restrictions right there. Two important clues. The 30 is important, the 570 is important. That's a special combination. Even more important is to know that we only have two types of coins, dimes and quarters. So how do we do this? What are we going to do? Folks, I'm going to use one variable. Now, if we have time in the show, if we have a little downtime or whatever, I'm going to come back and rework the problem using X and Y. We could use two variables, or in this case, D and Q for dimes and quarters. But I'm going to go with it as basically a one variable problem, and let's see how well we can work through it, all right? So the storyline goes, again, important numbers, obviously we have 30 coins total. So I got to define a variable. I've got two things I don't know. I don't know the dimes, I don't know the quarters. So what I'm going to do, I am going to let D equal my number of dimes. So far, so good. And what I'm going to do, also then you say, well, are you going to use another variable? That would make two variables, right? We're going to keep it with one variable. So, well, Ernie, how are you going to do that? Well, I know how many we have in all. So for example, if I have, let's say I have 10 dimes, it means I got to have 20 quarters. How to do that? I subtracted it from 30, right? 30 minus 10, taking 10 from 30 gives us 20. What if I'd had 5? Be 25, right? Because we subtract 5 from 30. So here's what we're going to do. We're going to let this expression 30 minus D equal the number of quarters. So now we're ready to work this thing through and keep it in one variable. We use the D as our variable here, all right? And keep in mind, that's the number of dimes, because it is going to be important in the end. We can't get those mixed up, because it will give us a different amount of money if we do. So let's play it out. First part of the question says we do have 30 coins. We've taken care of those. Now, how are we going to get this value? How are we going to get this value? Well, first of all, I'm going to change this $5.70 all into cents, 570, so we can avoid decimals here if we can. And underneath that part, then I know that a dime is worth 10 cents, right? So there we go, 10 cents. I know a quarter is worth 25. Now remember, our number of quarters is not Q. Now we could play that with a system type problem, but we're not doing systems on this. We're going to play it with one variable. So how about it? 30 minus that D value, because we're going to find the dimes. And our total is now, remember what we said we're going to do? We're going to make it cents, because that's 10 cents a dime, 25 cents a quarter, and we're going to make that 570 cents total. So don't worry about your decimal here. I think some of you get a little nervous about decimals. If we had kept $5.70, we would need to have the decimal in front of the 10, decimal in front of the 25 to work through. As it is now, it looks complicated enough for some of you. Are saying, yes, let's move this problem and go forward. So we've got 10D. Now it's time to do a little distributive property moment. We're going to take the 25 times that. And some of you could have said, Ernie, could we have put 25 on and maybe put Q's there and then 30 minus Q and put a 10 there? Certainly. Just remember what you're letting. That's why we define our variables to begin with, because we will know the number of dimes, and then we'll be able to find the number of quarters. So, but we're going after D first, it looks like. So it looks like dimes is going to be our story. We're going to distribute. That's going to give us, what, 750? Right, that's 25. Think about your money. There, 30 quarters. 750 minus 25D equaling there to 570. So we're ready to go. I need to put a D on that 25, because if I forget that, we'll have a problem, won't we? So we've got like terms right here. I got 10D minus 25D. How about it? We'll put a negative 15D plus 750 equaling to, what was that, 570 out here? That sounds good. Now let's not get too excited about the fact that we're going to have a negative 15D. Some of you say, we're going to have a negative number. Nah, what's going to happen here? We're going to follow the minus 750. Minus 750. And since I kind of like to go to the calculator on this one, let's take a look at it. I think we're going to get a negative 180, but let's make sure. We got 570, and we are going to subtract that 750. And it looks like, yes it is, it's a negative 180, which is a good thing. You say it's a good thing? Right, because we're going to be dividing this negative into a negative, and that, folks, is going to give us a positive answer, a number of dimes here. And that, by the way, we'll divide out. We'll just divide our negative 15 right through there. And it looks like we have 12 equaling D. So we have how many? 12 dimes. Now, easy way to figure this one out, yeah, let's go ahead and subtract. 30 minus 12, that's going to give us 18. Now, I put circles around because I usually like to wait and check. We are going to check. But we definitely know one part of the clue works. We've got 30 coins. And we have dimes and quarters. So that part's good. Now, the big question is, what's the amount? Are we going to have enough? So let's go back and say, well, we said 10 times 12, because we said a dime was worth what? 10 cents. So there we go. Plus 18 times our 25. All right. I know what 10 times 12 is. Everybody does, right? 120. This we have to think a little bit about. Well, 16 of those is $4. Add 50, so it looks like 450. Add those together, my friends, we are back at 570. Now, I know some of you probably played with the numbers at home and stuff like that and said, well, I eventually got to the point where I got them to work. But this kind of gets us going in one direction and gets us there. If you click and quick and go with it, you will have it probably found out quicker here than if there was maybe a very obscure or bigger number of coins and things like that, or a bigger value of them. So, but anyway, that's a great way to look at it. And if, like I said, we have time in the show, we don't have any big, we don't have some callers later in the show, we will come back and look at that with X's and Y's. And I think actually it's probably a little bit easier to work with X's and Y's, but I wanted to get that on our belt.